Um, Good morning to everyone. Um, we are going to present our project. The project is called the P300 Detect. Our group is made by Daniel Zuluaga, Juan Tovar, Luis Molina, Jose Luis Moreno, and me, Isaac Quasumal. Our project, or we choose this P300 spread because we consider it's very useful and really remarkable for patients that have a locked-in condition or a partial locked-in condition, so they can still communicate with the world through visual communication. The idea of this 300 speller is that the patient can communicate outside. Mm, the patient is given multiple characters, and through the VCI device, we can clearly recognize which is the character that the patient is thinking in in that moment, and at the end, he can communicate or he can present a clear message. Our dataset was given with 8 channels, the one that are shown in the figure. The dataset contained 150 targets and 1050 non-targets. Our sample frequency was given with 250 Hz, and we had information from 5 different patients. In this video, we present a little bit of one of our members trying the VCI interface and also the P300 splitter. What was our idea or solution? We use a bandpass filter between zero point 0.5 and 30 megahertz in order to remove low frequency and a high frequency noise. And then after we filter our data, we also use our windowing. And so two approaches were given, pre-stimulus and post-stimulus. For pre-stimulus were around 0 0.1, 0 0.2 seconds before trigger, and post-stimulus were 0 0.5 to 0 0.7 seconds after the trigger, which we also know that it's the window between the P300 wave is founded. Yeah, we present our findings and how is presented uh, before and after we do our filtering. For the data processing, we propose 3 different approaches. In the time domain features, we use mean amplitude, energy, and area under the curve. We also use PCA based feature using dimensional reduction to capture spatial temporal patterns. And also we use raw EEG features after our filtering. And we also use our classifiers such as KNN, LDA, QDA, and SVM. We present also here our pipeline of how the information was given, our data set, pre-processing, windowing, also feature extraction, the implementation of the classifiers, and then at the end, evaluation with metrics of performance. Um, Here we are presenting our confusion matrices for the outcomes with PCA. We also compare how was the accuracy. It's also important to say that our dataset was a non-balanced dataset because we had uh, different amount of values for our outputs. So we had more trials for our non-target and less for our target. So we not only focus on accuracy, but we also try to use different metrics of performance, such as a one score. Here we are presenting the outcomes with the time domain features, such as average features, energy, and area under the curve. We also use the time variant LDA for presenting our results. It was really interesting using this TVLDA because we had a very close approach so for the paper that was given, and we also prove the effectiveness of this classifier for this specific data set. At the end, we have a little reflection. We try to understand at the beginning um, how the user communicates and how the user interacts with this BCA, but also how it's important to do correct and accurate data processing. And here is the thing. But we also try to do a application, a graphic user interface. Our graphic user interface connect with the dataset, and what we do here is trying to create an environment where any user can interact with the information. So we present here the the trigger signal and which is the information for each channel. We also present different remarks about the information. Also, we have a window for filtering, different filters that we apply. It's also important that here we present how is the windowing and how is the signal after all this filtering and after this windowing. At the end, we have also the possibility to choose between the classifiers that we selected for this project. For the classification with only the raw data using area under the curve or using TVLDA multi-channel, and I think it's useful because it's easier to interact with the data set. Thank you very much.